Okay, picking up where we left off at, we did the distributive property of this binomial multiplied by this binomial. So 5 times 6 is 30, plus 5 times the square root of 2 is 5 square root 2, plus the square root of 2 times 6 is 6 square root 2, and the square root of 2 times the square root of 2 will give you the square root of 4. So we have 30 plus 5 square root 2 plus 6 square root 2 is 11 square root 2. Plus the square root of 4 is 2. So we have 11 square root 2 plus 32. And that is the final answer. Now we come over here to D. Now we do the same thing as we did for C. We would take 6 times 2 plus 6 times a negative 5 square root 7. As a matter of fact, let me go down here where I have more room. It'll be 6 times 2 plus 6 times the negative 5 square root 7 minus 3 square root 7 times 2 minus 3 square root 7. And I ran out of space here, so I'm going to write down, it'll be minus 3 square root of 7 times the negative 5 square root 7. Okay, now we have 6 times 2, which is 12. 6 times the negative 5 square root 7 will give us a minus 30 square root 7. A minus 3 square root 7 times 2 will give us a minus 6 square root 7. Now finally we had a minus 3 square root 7 times a negative 5 square root 7. Negative 3 times negative 5 is positive 15, and square root 7 times square root 7 is the square root of 49. So we had 12. Negative 30 square root 7 minus 6 square root 7 will give us a minus 36 square root 7 plus 15. And the square root of 49 is 7. So we would have 12 minus 36 square root 7 plus 15 times 7 is 105. So now we combine like terms, and we will have here, we will end up with 117 minus 36 square root 7. And that's it. Now we scroll down here to objective 3. And it says multiply conjugates. Conjugates are a pair of expressions in which one is the addition of two terms and the other is the subtraction of the same two terms. So now we multiply. Now these are conjugates. We have two terms here. One is subtraction, one is addition. So now we will have 1 times 1 plus 1 times the square root of 6 minus the square root of 6 times 1 minus the square root of 6 times the square root of 6. 1 times 1 is 1. 1 times the square root of 6 is the square root of 6. Minus square root of 6 times 1 is a minus square root 6. And then minus square root of 6 times square root of 6 is a minus square root of 36. So now we have 1. A plus square root 6 minus square root 6 is 0. So these will simplify each other out. Minus the square root of 36 is 6. So 1 minus 6 is negative 5. And that will be your final answer. Now, one thing I want to say to you, whenever you're dealing with conjugates, you really don't have to go through all of this multiplication. When you have conjugates multiplied by each other, and that's just two terms, one is addition, one is subtraction, you could do it much easier by doing this. You could take the first term times the first term, which would be 2 square root 3 times 2 square root 3, and then just take the second term plus 7 times only the second term. Now watch this. 2 times 2 is 4. Square root of 3 times the square root of 3 will give us the square root of 9. And then 7 times a negative 7 will give us a minus 49. Now we know the square root of 9 is 3. So it'd be 4 times 3 minus 49. So we would have 12 minus 49, which is a negative 37. Now we have to prove that this actually works. Now I just told you, to make it easy when you're dealing with conjugates, let's do the first times the first and the second times the second. But let's do it the long way like we did here, and we should still end up with a negative 37. So we would take 2 square root of 3 times 2 square root 3 plus 2 square root 3 times the negative 7. Then we would have positive 7 times 2 square root 3 and positive 7 times the negative 7. So 2 times 2 is 4. Square root of 3 times square root of 3 is square root of 9. And then a positive 2 square root 3 times the negative 7 will give us a minus 14 square root 3. And a positive 7 times 2 square root of 3 will give us a positive 14 square root 3. And positive 7 times the negative 7 will give us a minus 49. Now, we know this would become 4 times 3, because the square root of 9 is 3. And it's minus 14 square root 3 plus the 14 square root 3 will simplify each other out. And that's minus 49. So now, we would end up with 12 minus 49, which is a negative 37. So it actually works. So with the conjugate, you could skip all of this long step here and just do the first times the first term times the first term, and the second term times the second term, just to alleviate some of the time. Now we scroll here to section A for rationalizing the denominator. Objective 1, rationalize denominators containing one term. We simplify an expression of the form p over the square root of q by leaving no denominator as a radical. We call this process rationalizing the denominator. Now, example 1, simplify 2 over the square root of 5. Use your calculator to show that the simplified version has the same decimal value as the original. Now, you could do that at your leisure, but I am going to show you the steps of doing this problem. We would take 2 over the square root of 5, and we will multiply the numerator and denominator by the square root of 5 in order to make the denominator rationalize. Square root of 5 times the square root of 5 is the square root of 25. And 2 times the square root of 5 is 2 times the square root of 5. In our numerator, we will have 2 square root of 5, and the square root of 25 is 5. So in your calculator, you would compare what this would be versus this to see if they equal the same thing, which they do. Now, we scroll down here. It says to rationalize the denominator of a fraction of the form p over the square root of q, where q is positive, we multiply the fraction by 1 in the form of square root of q over square root of q. Now, in this previous problem here, our q was represented by 5 by the square root of 5. Our q was 5, and our p is considered to be 2. And so what I did was I was supposed to multiply the numerator and denominator by the square root of what q was, and we know q was 5 here. So we multiply the numerator and denominator by the square root of 5. And that's how we would solve that problem. So let's try this out on example 2a. Now, our square root of q here is the square root of x. So we multiply the numerator and denominator by the square root of x. 7 times the square root of x is 7 times the square root of x, and the square root of x over the square root of x is square root of x squared. So this comes out to be 7 square root of x, and we know the square root of x squared is just x. Now we go here to b. First we have to change this fraction and become the square root of x over the square root of 5. Now we have to get rid of this denominator by multiplying the numerator and denominator by the square root of 5. So this would give us square root of x times square root of 5 is the square root of 5x. And square root of 5 times the square root of 5 is square root of 25. So our final answer is the square root of 5x all over 5. Now we come to c here. Now we cannot simplify this fraction here. So we will go ahead and take the square root of 3a squared b all over the square root of 7. Now we multiply our numerator and denominator by the square root of 7. We cannot have a radical in our denominator. So our numerator would end up being the square root of 21 a squared b all over the square root of 49. Now in our denominator, that would be 7. But if you notice here, this a squared is a perfect square. We know the square root of a squared is a, and that's the only perfect square we have here. So our final answer would be a times the square root of 21b. And that's it. Now we scroll down here to example 3. Now what we have here is this here. We need to take this to be the square root of 5x over the square root of 18. Now we multiply our numerator and denominator by the square root of 18. Now the square root of 5x times the square root of 18 will give us the square root of 90x. And the square root of 18 times the square root of 18 is the square root of 324. Now the highest perfect square in 90 we know is 9 from a previous problem. So this would be the square root of 9 times the square root of 10x all over the square root of 324 is 18. So now the square root of 9 is 3 times the square root of 10x all over 18. But we could simplify this. 3 and 18 has 3 in common. So we'll divide the numerator and denominator by 3, and we'll be left with the square root of 10x all over 6. And that will be the final answer here. Okay, now we go here to B. We'll break this up. This will give us the square root of 7w squared all over the square root of 20. Now, I didn't do this in the last problem, but I'm going to address this here. We know the square root of 20 has a perfect square in it that we could pull out. And then we know the square root of 7w squared has a perfect square also. So this would be the square root of w squared times the square root of 7 all over the square root of 4 times the square root of 5. Now we know the square root of w squared is w. We bring over our square root 7. Square root of 4 is 2. And we add square root of 5. Now we have to get rid of this square root out of the denominator. So we'll multiply the numerator and denominator by the square root of 5. So now our numerator would become w square root of 35 all over 2 square root of 5 times square root of 5 is the square root of 25. So we had w square root, well, let me write it down here. We will have w, guess I don't want to write w square root of 35 all over 2 times 5. So our final answer would be w square root of 35 all over 10. And that is the final answer. Now we come to objective 2. Rationalize the denominators contained in 2 terms. Now basically what's going to happen here is you look at your denominator and you're going to multiply by the conjugate of that denominator. So we're going to do the numerator and denominator by the conjugate. As it says, to rationalize the denominator of the fraction of the form square root of p plus the square root of q over the square root of a plus the square root of b, where p, q, a, and b are positive, we multiply the fraction by 1 in the form of square root of a minus square root of b, square root of a minus square root of b, which is the conjugate of this denominator. So we look here at a. The conjugate of 4 minus the square root of 3, we know is 4 plus the square root of 3. And we multiply the numerator and denominator by 4 plus the square root of 3. And when we look here over at b, we will multiply by square root of 6 minus square root of 3, because that is the conjugate of that denominator. Now when we multiply, we know our numerator is just going to be 4 plus the square root of 3 here. Now remember what I told you with the conjugates. You could do the first times the first. 4 times 4 is 16. And the second times the second, which will give you a minus square root of 9. So it'll be 4 plus the square root of 3 all over 16 minus 3. And we know 16 minus 3 is 13. So that is the final answer here. Now, for this next problem B, we would take 6 times the square root of 6, which would give us 6 square root of 6, and then 6